Hello, this is Martha once again. We're from the Academic Support Center, and we're going to be working on some review problems for Pre-Calc 1. Let's get going. Hopefully we can cover problems 19 through 22. So let's start off. 19 asks us to find the inverse of a function. They give us three different ones. So remember the process for finding the inverse is you take your x and your y and you swap them. And then you solve for y. Solve. So let's take this first one, A, which is 7 over, y equals 7 over x plus 2. Now to solve this, we swap the x and the y. So x equals 7 over y plus 2. Now to solve this, we're going to multiply each side by y plus 2. So on the left side, we get y plus 2 times x equals 7. This allows us to bring that the denominator up to a numerator where it's a little easier to work with. Then we divide each side by x. We're left with y plus 2 equals 7 over x. To solve for y, we just subtract 2 from each side, so that gives us y equals 7 over x minus 2. And there we go. Now let's do b. For b, we're given the function of y equals the cubed root of x plus 4. So we swap our x and our y's, so we get x equals the cubed root of y plus 4. Now, as long as we do the same thing to both sides of the equation, we're in bounds and we're doing okay. So if we cube each side, that allows us to get rid of this cubed root. Then we're left with x cubed equals y plus 4. If we subtract 4 from each side, we're left with x cubed minus 4 equals y. And that's our inverse function. So moving along, we've got c, which is a little bit more complicated, but we've got y equals the square root of x plus 3 minus 5. And we've got the square root, but it would be helpful to have just the square root on each side. Oop, forgot to switch. So x equals the square root of y plus 3 minus 5. So if we add 5 to each side, we get x plus 5 equals the square root of y plus 3. And we're going to use that same trick of raising each side to the same power. So we get x plus 5, that whole quantity squared, equals y plus 3. If we subtract 3 from each side, we get x plus 5 squared minus 3 equals y. And that is our inverse function. So again, the process, and there's a process of putting the inverse function into the original. And if you get x out, then it's a true inverse. Now for this question 20, we're going to use the question 20, 21, and 22 actually, all deal with the vertex of a parabola. And that, if we have ax squared plus bx plus c, if we have this format, then we know that the vertex is, our x value is we take negative b and divide it by 2a. And then we put that in to the function, whatever value we get out, and that gives us the coordinates for our vertex. So let's look at 20. We get that y equals 2x squared plus 16x plus 9. That means my a is 2, my b is 16, and my c is 9. So we're going to take negative b divided by 2a. So we get negative 16 divided by 2 times our a is 2. that gives us negative 16 over 4, which gives us negative 4 for our x value. And so we put that in to get our y value. So we get y equals 2 times negative 4 squared plus 16 times negative 4 plus 9. So we're going to walk through this a little bit. Negative 2 squared, or sorry, negative 4 squared is 16. So we get 2 times 16. And 16 times 4 is negative 64 plus 9. 2 times 16 is 32. And 32 is half of 64, which makes it a little nicer. So we get that negative 32 plus 9, or negative 23. So the vertex of the function is at negative 4, comma, negative 23. Now for 21, I'm going to assume that they want you to go through the process of order of operations and use the same negative b over 2a to find the vertex. So let's go through this order of operations. We've got 2 parentheses x plus 2 all squared minus 2. And it's crucial how we do the order of operations. So the first is the exponent. And that leaves us with 2 times x plus 2 times x plus 2 minus 2. And I would advise foiling at this point. So we're going to FOIL our x to the x to the 2. And then our 2 to the x and 2 to the 2. So we get 2 times x squared plus 2x plus 2x plus 4 minus 2. Now we want to take and simplify this to 4x, and we're going to distribute this 2 through. Teach one. So this gives us 2x squared plus 4x times 2 is 8x plus 2 times 4, which is 8. And then this 9 minus 2, we finally get to incorporate that in. So our final formula for this vertex is 2x squared plus 8x plus 6. Luckily, right now we still want to worry just about our a, which is 2, and our b, which is 8. So we want to do negative b, which is negative 8, over 2 times 2. And that gives us negative 8 divided by 2 times 2 is 4, which gives us 8 divided by 2, or negative 2. Now we can put this negative 2 into this function right here, but we've got a nice kind of workaround. If we go back to the beginning, we use the formula from the very beginning. We take 2 times that negative 2 plus 2 minus 2. This just saves us a little bit of work, which is nice, because negative 2 plus 2 is a big old 0. Anything times 0 is 0, so we end up with getting 0 minus 2 for our y value. So our x is negative 2, our y is negative 2. And that saved us a few steps. So the next one that we're going to do is find the minimum point. Okay, so how do we know the minimum point? If we use our knowledge of in patterns, or in behavior, that's the word, we know that this is an x squared and it's positive, so it's going to follow this parent function. And the minimum point is the vertex. If it were a negative x squared, the vertex would be the maximum point. So we want to find the minimum point. Our equation is 2x squared plus 8x plus 9. Oh, hey, that's looking familiar. So we do negative b over 2a. Our b is 8, so we take negative 8 divided by 2 times 2. And negative 8 divided by 2 times 2 is 4, and that gives us negative 2 once again. Now we have to go through and put it into the equation. So we get 2 times negative 2 squared plus 8 times negative 2 plus 9. Let's see what that gets us. Negative 2 squared is 4, so we get 2 times 4. And 8 times 2 is negative 16. And then we get plus 9. So we know that 2 times 4 is 8. 8 minus 16 plus 9. 8 minus 16 is negative 8. Negative 8 plus 9 is 1. We know that our minimum point, our minimum point for this upward facing parabola is negative 2, 1. All right, we're going to keep having some fun with these videos. Hope this helps.